We're here today to show the differences in the engineering and technology behind the Tsunami compressed air filtration products. We're going to be comparing these products to the generally accepted practices found in industry today. The methods of the filtration are generally over 50 years old. The way this technology works is this is a centrifugal technology. So when the air comes in here, it comes in from the top and it will start to spin, and it hits these baffles here. And as that air spins, if there's any liquids, droplets, theoretically that droplet's supposed to fly out and it's supposed to hit the inside of the bowl here and run down to the bottom. Well, if you have about an 80% rated flow, continual smooth flow, they work pretty good. But what happens all day long is you have periods of really low flow or no flow, and you have real high flow. Person's using an air tool, turns it on and off. Squeeze a trigger on a paint gun, you're using air, hit a tire changer, inflate a tire, so you get big bursts of air that happens in your shops and your plants all day long. And your elements are all right up at the top. Those droplets come in and they'll impinge themselves right against that element. And the liquid will be driven right through that porous element. So you get water and oil droplets that'll carry over downstream. We'll stop the particulate. Really low flows of air, you don't have enough energy to get the droplets to the sides of the bowl. So what happens is the droplets hang down off these little baffles. Well, now when you do have pulses of air or demands of air, being that they're just dripping on here, you get that demand of air, that droplet's pushed right against that element, goes right through the element, you can carry that liquid downstream. Now the differences in technology that we use is we come in from the top, we send the air vertical going down, so we have gravity and we have speed and velocity working with us. So we're sending that air down. When it hits the bottom down here, we come out through these air channel slots. When it hits this air channel slot, we'll hit this diverter plate. What that does, that spins the air. We redirect the air 180 degrees. Most of the particulate and liquids are driven down past here, down to the drain sump, where the automatic drain takes it out. What we do is when we switch direction, if you look here, the area here is much larger than the area inside this tube. So we immediately slow the velocity down. Well, it's very hard for liquid to stay entrained in an airstream that's moving very slow. So the liquids generally stay down here. When we come up here, we come up through this baffle plate right here, which has a series of holes. Now what we do is we accelerate the air coming up through this stainless steel mesh, something you never have to change, it's stainless steel. As the air comes up through here, it changes direction millions of times and it creates little vortices. And each time that air turns and spins, it coalesces out a droplet. That droplet, if you can see the spiral here, runs to the outside of the wall, and since we have a really low velocity come up here, the water droplets are able to run down to the bottom of the drain sump where the automatic drain will eject them. Once we make it clear through the top, we come way up to the top before we send the air downstream. So what we've done is we've done this big reversal here, this big directional change from down here way up to here. Very different than anything out there as far as technology goes. Another couple engineered features of the product is we come standard with an automatic drain on both our coalescing filters and our water separators. So when liquids do accumulate in the drain sump at the bottom, these float drains will raise up and eject the condensate. If you have really dirty, rusty air, we have an option of our electronic solenoid valve to screw onto the bottom of here without any additional plumbing, and that will eject it for a dirtier system. We machine our tubes out of 6061 aluminum, and we anodize them both inside and out for corrosion. Here's some typical way manufacturers manufacture. Most are die cast. Check out the contamination in here. It's a die cast bowl, and any chemicals that are in your compressed air will eat away at that aluminum, get like white rust. Here's another filter that's just a die cast housing. Here's another die cast housing. The drains sit right on the very bottom, so if there's any contamination in there, it goes right to the drains, and the drains will fail eventually. And some of the coalescing filters, again, they're uncoated on the inside, and also they have no automatic drains on them. One thing guaranteed about a float drain, it will fail. It's just a matter of time. What normally fails is you get garbage, rust, debris that gets inside these screens and gets up inside the workings of the valve, and they'll fail. Since they do fail, you need to design your system so if it does fail, within a matter of a few seconds you can take it out and you can replace that drain there. Here's some competitive filters. If you take a drain, you can't even get your hand in there. How do you try to get down in there to hold it? If you notice, the drains are at the very bottom, so any rust and debris goes right to the bottom. On our Tsunami, this little lip right here, we elevate the drain up about 1/4 inch, so we have a sediment trap right there. So if there's any dirt or sediment, it'll give you longer life before that drain fails. Here's another one. Nice filters, coated. Just try to get it so you can replace that drain in there and get it in that hole. It becomes very, very difficult. Another key design characteristic of the Tsunami is the heads. They're machined from 6061 aluminum. They're either anodized or anodized and powder coated. It's the inside of your filters that's the most important part for having the coatings. What happens is you get die-cast bowls, and if you look inside there, you can see all that white rust and contamination. Well, the outside looks beautiful, but your contamination that gets downstream in your paint jobs, that gets stuck in your valve, that little white rust, aluminum oxide, you can see around that die-cast housing, you can see all the corrosion. That's your downstream air, so that's supposed to be your clean air. So you just go through this really nice element, you get good clean air, but then it's exposed to that downstream, unanodized, non-coated features, and that's where your contamination comes from. We're going to show a demonstration of the performance of our Tsunami filtration system. What we have here, the first stage of this filter is a Tsunami automatic water separator, and we have this coupled with a Tsunami oil coalescing filter. What we've done for demonstration purposes is we have an airline and we have a tank of water, and we've injected some red dye into this tank so it makes it a little bit easier to see what's going to happen here. We're going to create a tsunami, so we're going to start bringing some air through here with some water. We've created our tsunami. And you can see this is where the fluid's exiting the filter. That's a lot of water. That's a tsunami worth of water.